Welcome to Two Projects. In this video, we are going to explain the project Traffic Prediction and Detection using Machine Learning and Yolo. Before diving into the execution, let me give you an overview of the project. So, traffic congestion is a major issue in cities, leading to delays, wasted fuel, and more pollution. Traditional methods of predicting traffic often use historical data and simple methods which may not work well for today's complex traffic patterns. So, being able to predict and detect traffic accurately is very important for keeping roads running smoothly and ensuring safety. Machine learning helps by analyzing lots of data to make better predictions, while advanced algorithms like YOLO quickly spot things like accidents or heavy traffic in images. By using these tools, we can make traffic flow better, reduce congestion, and make roads safer for everyone. So, in traffic prediction and detection, machine learning models analyze historical data to predict future traffic conditions, considering factors like day of the week, road features like car count, bus count, bike count, etc. While deep learning models such as YOLO are used to quickly and accurately detect traffic density from images, categorizing it as high, medium, or low traffic. So, this allows for timely responses to traffic situations. YOLO's efficiency lies in its ability to process images rapidly, aiding in real time detection tasks. Together, machine learning and deep learning models contribute to optimizing traffic flow, reducing congestion, and enhancing road safety. So, we will be using machine learning for prediction and deep learning for detection in this project. Now, we look at the workflow. So, the workflow begins with understanding the dataset, exploring its characteristics related to traffic flow, vehicle types, and environmental factors while also identifying data sources, formats, and potential challenges. And exploratory data analysis, that is EDA, is conducted to visualize traffic data distributions, trends, and correlations, gaining insights into traffic patterns and peak hours. Following this, data pre processing steps are executed to clean the dataset by removing duplicates, handling missing values, and standardizing data formats, preparing it for analysis and model training by encoding categorical variables and performing feature selection. Subsequently, model development involves splitting the dataset into training and testing subsets. Train set is for training the models, and test set is for evaluating the model's performance. And we will utilize various machine learning algorithms like SVM, AdaBoost, XGBoost, along with ensemble methods to build prediction models, which are then evaluated and fine tuned based on performance metrics like accuracy, precision, recall, and F1 score. And for traffic detection, the process involves pre processing images for object detection using techniques like blob conversion and bounding box definition. YOLO and other deep learning models such as FASTA RCNN, SSD, RetinaNet are specifically trained to detect traffic density into high, low, and medium classes from images. So, this is what we'll be doing in this project. And integration with the Flask framework involves the development of a user friendly web application, allowing individuals to securely register and log in using SQLite for authentication purposes. Upon authentication, users gain access to functionalities enabling them to input data or upload images via the interface for traffic prediction or detection tasks. This integration significantly improves accessibility and usability, offering a smooth and efficient platform for users to interact with the traffic prediction and detection system seamlessly. Overall, the project aims to benefit city planners, transport authorities, drivers, and emergency services by providing accurate traffic prediction and detection through machine learning and deep learning models. Objectives include developing user friendly web interfaces, improving traffic management, and enhancing road safety by leveraging advanced technologies for efficient prediction and detection. Now we'll look at the software and hardware requirements to execute this project. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, backend framework needed is Jupyter Notebook, database required is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we'll look at the algorithms built. So, as I mentioned earlier, we have built machine learning algorithms for prediction task, and we have built deep learning models for detection task. So, after comparing these machine learning models using different performance metrics like accuracy, precision, recall, and F1 score, we have concluded that voting classifier has outperformed all other models, SVM, AdaBoost, and XGBoost, in all the performance metrics. And in these deep learning models, after comparing all these models using performance metrics like precision, recall, and MAP scores, we have observed that Yolo V5X6 has outperformed all other models in all the performance metrics. So we have deployed voting classifier and Yolo V5X6 into the Flask web application. Now we'll understand about these algorithms, voting classifier and Yolo V5X6. So voting classifier is an ensemble learning technique where multiple individual classifiers such as AdaBoost classifier and random forest classifier in this project are combined to make a final prediction. During training, these base classifiers learn from the dataset, and during prediction, their outputs are aggregated using a voting mechanism, either soft or hard voting. In soft voting, the prediction probabilities are averaged, while in hard voting, the majority vote determines the final prediction. In this project, we have used soft voting. So, by harnessing the diverse strengths of the base classifiers, the voting classifier aims to enhance prediction accuracy. So, this is about voting classifier. Now, coming to YOLO V5X6, first we'll understand about YOLO. So, YOLO, that is You Only Look Once, is a computer vision object detection algorithm that quickly identifies objects in images by splitting the input image into a grid and simultaneously predicting bounding boxes and class probabilities. Unlike traditional methods, YOLO processes the image just once, making it extremely fast. It predicts multiple bounding boxes and their associated class probabilities for each grid cell and then removes redundant detections using non maximum suppression. So, this results in a final list of detected objects along with their bounding boxes and probabilities. So, this is how YOLO works. So, these are different versions of YOLO. Coming to YOLO V5X6, it is a variant of the YOLO V5 object detection model designed to strike a balance between accuracy and speed. With around 2.4 million parameters, it offers good precision and recall while maintaining efficient processing speed. Its architecture is optimized to handle 1280 by 1280 input images, making it suitable for real time object detection tasks. So, YOLO V5X6 is chosen for this project due to its ability to provide accurate and fast detection, making it well suited for identifying traffic in images. So, its medium sized architecture and optimized parameters allow for efficient processing of images while maintaining high detection accuracy, aligning perfectly with the project's objective of enhancing object detection capabilities in complex environments. So this is about the YOLO V5X6. Now we'll look at the execution. So before executing the project, first we have to open the code folder which contains the project source code files. This is the code folder and these are the contents I have in the code folder. This is sample folder in which I have test images on which we'll make the detections. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. These are YOLO V5, YOLO V6, YOLO V7, and YOLO V8 folders in which I have dataset to train that particular models. So I'm opening YOLO V5 folder. So we can see I have train and validation folders here. I am opening train folder. So in images folder, I have these images of traffic of different classes, high, medium, and low traffic. And in labels folder, I have annotation files. So each label file or annotation file corresponds to an image file in the images folder, providing details about the objects, locations, and classes within the image. So this annotation file corresponds to this image. Similarly, this annotation file corresponds to this image. In the same way, each annotation file corresponds to an image in the images folder. So these label files or annotation files follow the YOLO format where each line, so this is the line, represents a detected object. So each line specifies a object's class index. The first column is the class index, followed by its bounding box coordinates. So these are the bounding box coordinates. This is the X limit, this is Y limit, this is the width, and this is the height. So in this image, there is one object detected as the line represents a detected object. And in the second image, we can see there are two objects detected. In third image, we can see there is again one object detected. And in this line, first column is the class index and these are the bounding box coordinates of the detected object. So similarly, I have bounding box coordinates and the class index in the other label files also, indicating a detected object corresponding to a image file in the images folder. So on these label files and on the images, we will be training the YOLO V5 model as it is in the YOLO V5 folder. So here we can see I have train and validation folders. In validation folder also I have images and labels. So on these images and label files, we'll be evaluating the model's performance. On the images and label files in train folder, we will be training the models, and on the images and label files in the validation folder, we will be evaluating the model's performance. And here we can see I have separate folders for YOLO V5, YOLO V6, YOLO V7, and YOLO V8. Each folder contains the same images, but they are annotated differently. The label files, the annotation files will be changing, because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. And having separate folders like this helps keep the dataset organized and ensures that each YOLO version receives the correct annotations it needs to function properly. That is why we have different folders for different models. Now coming to app.py file. So this .py file contains the information related to front-end logic. It includes code data in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And these are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is detection Jupyter source file and this is prediction Jupyter source file. So these Jupyter notebook files contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. So these are respective Jupyter source files. This is signup.db file. This file is the database file used to store user information. And this is traffic CSV file in which I have traffic dataset for prediction task. So we can see these are the column names I have: time, date, day of the week, car count, bike count, bus count, truck count, total, and traffic situation. In traffic situation, I have low traffic, normal traffic, heavy traffic. So these are different classes I have. So on this dataset, we'll be training the prediction models, the machine learning models. And in sample files, I have test cases for prediction. So this is about the code folder. Now copy the path of the code folder from the address bar of the file Explorer. This is the path, I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command executes the Python script and performs a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. So this is the local host and this is the port. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. Here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this login link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the predictions page. As default, after signing in, the application will redirect us to the predictions page. If we want to perform detection task first, we can do that by clicking on the prediction link here. If we want to perform prediction first, we have to select features, and if we want to perform detection task first, we have to select image here. First, we'll perform the prediction task. Click on features link. So now we have to fill in these parameters and click on predict button to get the traffic estimation. So first we'll understand these parameters. So date indicates when the traffic data was recorded, and day of the week, here we have to select the day of the week from Monday to Sunday. And car count is the number of cars observed. Bike count is the number of bikes observed. Similarly for bus count and truck count. And total vehicles is the sum of all vehicle counts, providing an overall measure of traffic volume. So now we have to enter these parameters. Date would be 4th. Day of the week is Saturday. Car count would be 15. Bike count is 5. Bus count would be 0. No buses. Truck count is 10 and total vehicles count is 30. Now click on predict button. So here we can see the result, that is the traffic is low. According to the given set of parameters, the application has predicted the traffic as low. Click on prediction link, click on features link. We'll try giving another set of parameters. Date this time would be 8th. Day of the week is Wednesday. Car count would be 86. Bike count is 15. Bus count is 15. Truck count would be 23 and total vehicles count is 139. Now click on predict button. So here we can see the results, that is the traffic is high. According to the given set of parameters, the application has predicted the traffic as high. We'll try again. I'm giving date this time as 22nd. Day of the week is Saturday. Car count would be 146. Bike count is 23. Bus count is 23. Truck count is 4. Total vehicles would be 196. Now click on predict button. Here we can see the traffic is heavy. So according to the given set of parameters, the application has predicted the traffic as heavy this time. Date this time would be 7th. Day of the week is Tuesday. Car count would be 102. Bike count is 5. Bus count is 19. Truck count is 11. And total vehicles would be 137. Click on predict button. So here we can see the result, that is the traffic is normal. Similarly, we can give any set of parameters and can get the predictions. We'll try with one more set of parameters. So date this time would be 24. Day of the week is Thursday. Car count is 116. Bike count would be 23. Bus count is 23. Truck count would be 4. Total vehicles would be 166. Now click on predict button. So here we can see the result, that is the traffic is normal. According to the given set of parameters, the application has predicted the traffic as normal traffic. Now we'll perform the detection task. Click on image link here. So here we have to upload any traffic image and the application will categorize into heavy, medium or low traffic. Click on choose file button. From sample images folder, these are the test cases I have. Select any image. I'm selecting this one. Click on open. The image has been loaded. Now click on upload button. So we can see this is the uploaded image and we can see the bounding box drawn around the detected condition. And the application has classified the traffic level as high traffic. Here we can see the label. And beside the label, we can see a probability score telling us the confidence level of the application in classifying this traffic level as high traffic. Click on back, click on choose file. We'll try uploading another image. I'll try with this one. The image has been loaded. Now click on upload button. So we can see the application has detected no or low traffic. It has drawn a bounding box around the detected no or low traffic. Here we can see the label and beside the label we can see the probability score telling us the confidence level of the application in classifying it as no or low traffic. Click on back, click on choose file. We'll try with this image. Select the image, click on open and click on upload button. So we can see the application has detected the traffic. It has drawn two bounding boxes here. It has detected moderate traffic this side and it has detected low traffic this side. We can see the class labels here, and we can see the probability scores beside the class labels, telling us the confidence level of the application in classifying the traffic levels into that particular class. Click on back. So similarly, we can upload any image from the test cases and can get the class detections and classifications. I'm uploading this image. Click on open. The image has been loaded. Now click on upload button. So we can see the application has detected the moderate traffic and high traffic. We can see the bounding boxes drawn. We can see the class labels and we can see the probability scores. Click on back. We can also upload images taken from Google. We'll try that. So I'm searching for traffic images. So these are the results I've got. I'll upload this image. First, download the image. Click on choose file. Select the downloaded image and click on open. The image has been loaded. Now click on upload button. So we can see the application has drawn a bounding box around the detected traffic. It has classified the traffic level as high traffic. And beside the label, we can see the probability score telling us the confidence level of the application in classifying it as high traffic. Click on back. We'll upload another image. I'll try with this one. Download the image. Click on choose file. Select the downloaded image and click on open. So it is saying only JPG or JPG files are allowed. Okay. We'll try uploading another image. I'll try with this one. Download the image. Click on choose file. Select the downloaded image and click on open. The image has been loaded. Now click on upload button. So we can see the application has detected no or low traffic this side and it has detected high traffic this side. We can see the bounding boxes drawn on two sides. Click on back. We'll try with another image. We'll try with this one. Download the image. Click on choose file. Select the downloaded image and click on open. Click on upload. We can see the application has drawn a bounding box around the detected traffic. It has classified the traffic level as high traffic. And we can see the probability score here. Click on back. So in this way, we can take images from Google also and make the detections. I'll try with this image. Download the image. Click on choose file. Select the downloaded image and click on open. Click on upload. We can see the application has detected high traffic this side and it has detected low traffic this side. Click on back. Now click on graphs link. Here we can view all the visualizations made. So this is precision and recall graph of Yolo. This is F1 score graph of Yolo. This is confusion matrix graph. In this graph, the diagonal boxes are the correct classifications and the remaining boxes are the misclassifications. This is precision scores comparison graph, a horizontal bar graph comparing precision scores. So in this graph on x-axis, I have precision scores and on y-axis, I have algorithm names. So these are the algorithms built for detection. This is recall scores comparison graph. Similarly, this is MAP scores comparison graph. So we can see in all these three graphs, YOLO V5X6 has outperformed all of the models. And these graphs are for prediction task. So this is sample outcome graph. which displays the distribution of labels. So here on the x-axis I have labels and on y-axis I have count. So we can see there are more number of labels, there are more number of cases with normal traffic level, and there are very few cases of low traffic level. This is correlation matrix graph, which tells us if two features are related or not. This is accuracy scores comparison graph. In this graph on x-axis, I have accuracy scores and on y-axis, I have algorithm names. So these are the algorithms built for prediction task. Similarly, this is precision scores comparison graph. This is recall scores comparison graph, and this is F1 scores comparison graph. So from all these graphs, we can see that voting classifier has outperformed all of the models in all the performance metrics. So these are the graphs. Now click on sign out. So the project successfully enhances traffic management through accurate prediction and detection, benefiting city planners, authorities, drivers, and emergency services. By leveraging machine learning and deep learning models along with a user-friendly interface, it improves overall traffic efficiency and road safety for all stakeholders.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.